Assalamualaikum and good morning, respected judges, lecturers, and representatives from the Ministry of Transport. Today, I would like to introduce our purpose project, Skylink JBSG Connector, an AI-powered solar cable pod feeder system designed to improve mobility for Johor Bahru residents who commute daily to Singapore. Johor Bahru is one of the most important gateway connecting Malaysia and Singapore. According to the Iskandar Regional Development Authority IRDA 2024, this corridor supports significant economic activity and workforce movement between both countries. However, the growing numbers of daily commuters has created a major transportation challenges. Based on the TomTom Traffic Index 2024, congestion remains a serious issue, particularly on the routes leading to JB Central and the CIQ complex. Many commuters spend a considerable amount of time traveling to transport hub while also facing a higher fuel cost and increased travel stress. In addition, existing transport systems mainly focus on cross-border travel itself, but they do not fully address the first mile and last mile connectivity challenges experienced by commuters traveling from residential areas such as Bukit Indah, Medini, and Iskandar Putri to JB Central. Therefore, our project aims to develop a sustainable and resilient transportation solution to improve accessibility, reduce dependence on private vehicles, and support more efficient commuter movement. Our objectives are to reduce travel time by 30%, reduce traffic congestion by 15%, increase public transport ridership by 25%, and reduce carbon emissions by 40%. Through this initiative, Skylink JBST connector has the potential to create a smarter, greener, and more efficient transport ecosystem for Johor Bahru. Thank you.
Good morning, everyone. My name is Nur Afika. Let's look at Johor's mass transit landscape. The crown jewel is the upcoming RTS Link, built to move 10,000 passengers per hour across the border. But while this solves the cross-border bottleneck, it exposes a massive internal gap. How do commuters actually reach the terminal? Right now, residents in sprawling suburbs like Mount Astin and Bukit Indah face severe daily gridlock just trying to get to the RTS station. Johor excels at heavy tram lines, but completely lacks a traffic-free first and last mile feeder network. To solve this, we look at Bolivia's Mi Teleférico, the world's largest urban cable car system. But JB doesn't need another heavy tram line. It needs a flexible feeder. Furthermore, building traditional LRT or extra road lanes through JB's dense suburbs is physically and financially impossible due to tight land acquisition constraints. We must think above the gridlock without tearing up the ground. This is why we designed Skylink Pods, an AI-driven solar-powered autonomous pod system. By installing lightweight, elevated pylons directly onto the center medians of existing highways, we optimize air rides and bypass ground traffic entirely. Unlike traditional gondolas that run continuously, Skylink uses an on-demand dispatch model, deploying pods dynamically as cross-border commuters arrive. Beyond avoiding traffic, Skylink stations double as decentralized solar microgrids powered by 100% clean energy. The network is completely insulated from volatile fuel price shocks and subsidy cuts. Skylink is weather resilient, has zero ground vulnerability, and delivers the missing link JB commuters desperately need. So, let's take Johor Bahru's transit to the next level. Thank you.
Assalamualaikum. So I will present the innovation and system design for our Skylink JB Singapore connector. Skylink is an autonomous area cable pod that system designed to improve daily travel between Johor Bahru and Singapore. So by operating on elevated cable network, it avoids the road congestions and it provides a faster, safer, and more sustainable commuting experience. So I will propose a route that consists of 4 stations. First is Bukit Indah, second Sutra Mall, JB Central, and lastly CIQ Complex. Bukit Indah was selected because as a major residential area, while for Sutra Mall as a commercial hub, JB Central, and the JB Central is the main transport interchange, and the CIQ Complex as the gateway for cross-border commuter. So this system includes 4 autonomous cable pods that carry 4 until 8 passengers. And we do also a solar power station, AI demand predictions, and a mobile application for booking that control as a cashless payment, and a real-time tracking. And with this, all the technologies is improve efficiency and reduce waiting time and provide a more convenient travel experience. And finally, we do have an operational flow that begins with the passenger book at a port through the mobile app. And the AI control center will assign the nearest available port. After that, the passenger will scan their QR code at the stanger nearby, and they will board the port and travel directly to JB Central or the CIQ complex. So after the passenger exits, the pod is automatically reassigned for the next journey. So overall, Skylinks offer an innovative, smart, and sustainable solution for the future cross-border transportation.
Now, I will be presenting the operational resilience, sustainability, and risk management of the Skylink JB Singapore connector. First, Skylink is designed to remain safe, reliable, and operational even during fuel price increases, traffic congestion, and energy disruptions. Unlike conventional road transports, which relies heavily on fossil fuels, Skylink uses fully electric propulsion with solar photovoltaic integration. This reduces dependence on imported fuel and helps maintain stable operating costs during global fuel price fluctuations. In the event of a fuel supply disruptions, Skylink can continue operating using locally generated renewable energy, making the system more energy secure and resilient. During peak congestions at the Johor Bahru CIQ, the elevated guideway allows Skylink to bypass road traffic completely, providing a consistent travel time of 10 to 80 minutes. Compared with the current road-based system, Skylink offers greater reliability through electric power, low operating costs, and an elevated infrastructure that is separated from road congestion. It also achieves an operational availability of 99.7% to 99.9%. From a sustainability perspective, Skylink can reduce approximately 70,000 tons of CO2 emissions annually compared with conventional buses and private vehicles, according to Jacobs 2016. In addition, solar-powered pods produce 98% lower emissions than diesel shuttle buses, according to Fuhrman et al. 2021. The system also aims to increase public transport ridership by 25% through reliable last-mile connectivity. To ensure resilience during emergencies, Skylink incorporates redundant power systems, real-time monitoring, cybersecurity protection, and fail-safe operations. If the main power supply fails, the system can switch between solar power, the national grid 9.8 megawatt battery storage, and diesel recovery motors to safely return passengers to the nearest station. Overall, Skylink demonstrates a highly resilient and sustainable transport systems that can continue operating during major disruptions while providing safe, reliable, and environmentally friendly cross-border mobility.
Our financial analysis indicate that the proposed Skylink is economically feasible and financially sustainable. The project adopts a PPP, public-private partnership model, allowing the government and private investors to share financial and operational risks while reducing fiscal pressure. The estimated capex is 400 million ringgit, benchmarked against international urban cable transit system and adjusted for JB's local condition. The projected annual OPEX is 30 million ringgit, equivalent to 7.5% of capex, supported by AI-enabled predictive maintenance and solar photovoltaic technology. Based on the financial evaluation, Skylink is projected to serve approximately 44,000 passengers daily, generating an estimated 100 million ringgit in direct annual economic savings through reduced travel time, fuel expenditure, and vehicle operating costs. The project is also expected to achieve an estimated 20.6% ROI with 4.9-year payback period, demonstrating strong long-term financial viability. Although the project requires substantial upfront investment and depends on achieving the projected ridership, the projected economic returns and operational efficiencies indicate that the investment is financially justified over the long term. In conclusion, Skylink delivers value beyond fare revenue by improving transport efficiency, supporting regional economic activity, and strengthening connectivity within Johor Singapore Special Economic Zone. As a smart feeder system complementing the RTS link, it has the potential to become a financially sustainable solution for future cross-border mobility. Overall, Skylink represents not only an investment in transport infrastructure, but also a strategic investment in Johor Bahru's long-term economic development and regional connectivity. That's all from us. Thank you.